Hello, welcome to S Chemistry. I am your instructor Dr. Suhas Gavi, and today I will be teaching BSc 5th semester Physical Chemistry course on electrophoresis. So let us start with the outline. First, I will introduce about what is meant by electrophoresis. Then I will cover theory of electrophoresis, then applications. So let us start with introduction. Electrophoresis is defined and discovered by Tesselus. Arin Tesselus was a Swedish biochemist who won the Nobel Prize for chemistry in 1948 for his work on electrophoresis and absorption analysis, especially for his discovery concerning with the complex nature of the serum proteins. So he was the first Swedish biochemist who used this electrophoresis technique. So now we will see uh, what is in by electrophoresis. So as you can see in right hand side, one tube, U shaped tube is there, glass tube, where inside one solution is filled, that is deionized water, and it also has some arsenic sulfide solution particle, and platinum, this is embedded with platinum electrode, which is connected to the positive and negative end of the electric potential. Now we are going to see how this electrophoresis solution will work. So the moment of solution particle under an applied electric potential is called the electrophoresis. So after applied of electric potential, this particle, whatever the inside is there, that may be charged. So due to this charge particle, the movement will happen after applied electric potential. So it can go either positive or negative. So based on that we will decide so this phenomena we call it electrophoresis or cataphoresis. So we will see what are the parameters. So solid particles and the liquid medium carry opposite charges. So there are two components. One is particle, that is solid particle, which is solvated in the particular liquid medium. So first condition is your solid particle has different, it should carry different charge, particle and liquid medium. So both should have opposite charge. Then if you applied the electric field to this solid particle or liquid medium, so it will migrate in opposite direction. So one will go here positive end and another will go in negative end. So that is the first criteria. So the phenomena known as electrophoresis occurs when tests are set up such that the particle moves but the medium remains stationary. So the phenomena known as electrophoresis occurs when tests are set up such that the particle move but the medium remains stationary. So in electrophoresis, your only moving is the particles, and your whatever the medium is there, here they have taken as a deionized water. This medium remains constant or stationary. So only one is moving. So that phenomena we call it electrophoresis. Now we will see the theory of electrophoresis. So what is the theory of electrophoresis? So by noting the direction of movement of solution particle, we can determine whether they carry positive or negative charge. So if you applied the electric field to this U-shaped glass tube, so your particle either will go positive no electrode or negative electrode. So based on that you can decide your particle has in positive charge or negative charge. They are carrying positive charge or negative charge. So if electric potential is applied across these two platinum electrode dipping in the hydrophilic solution, the dispersed particle move towards one on the other electrode. So it can go here or here, so depending on the what carry the positive or negative charge. So, suppose if the solution particle migrate towards the positive electrode, then they carry the negative charge. On the other hand, if they move towards the negative electrode, then they carry the positive charge. So here here it should be negative electrode and here it should be positive charge. This is the correction. Now using water as the dispersed medium, the charge on the particle of some common solution determined by electrophoresis is given below. Now we will see if we use dispersion medium as a water, what are the possible examples that can be used as a electrophoresis technique. So first we will see the examples of negative charged solution particle. So first example is metal, that is gold, silver or platinum. Another example is arsenic sulfide. It also has a negative charge particle when you put into the electrophoresis. Third example is starch, then clay. So starch also has negative charge. When you apply the electric potential to the U shape tube, then it will attract towards the positive electrode. So now we will see what are the positive charged particles are there. So there are four examples I have mentioned given here. So first example is ferric hydroxide, which carries a positive charge. Second is aluminum hydroxide. Third is basic dye, and fourth example is hemoglobin, our human blood. So here they also they are positively charged if you put into the dispersed water dispersed medium. So if you apply the electric potential, so this atom will go, it will attract towards the negative. Positive charged particle will attract towards the negative electrode and negatively charged particle will attract to the positive electrode. So this is the basic difference. Now we will see what are the application of this electrophoresis. So first application is to remove any particles. Suppose you want to remove from the any gas solution. So your solution can be either water or any liquid or gaseous. So in chimney they are filled with the complete gases. Suppose you have any charged particle is there in the smoke, you can definitely take out from the, or you can remove through this electrophoresis technique. Another application is you also can remove or suspended impurities of a suspended impurities. If you have in water you have some positive or negative charge particle is there, then it is very easy to purify your water or any solvent. Another example is to deposit. Either you can remove or you can deposit. So electroplating is a deposition technique where you can use, if you want to coat with rubber on particular metal surface, you can use a latex as a solution particle. So definitely you can use as a latex as a solution particle to coat on particular metal. Suppose you want to coat on iron rod or you want to coat on cobalt, you can use this electroplating technique. For chroming plating, you can use this electrophoresis technique. Fourth example is painting of metals part. So if you have painting of metal parts of cars from colloidal pigments. Suppose you have car, that object you want to paint it. So car is made up of stainless steel and you want to paint on that. So from colloidal pigments of the solution, you can definitely can able to paint the metal part. So here we came to end of this lecture. So these are the references for the images, and these are the references for the content. So you can follow this book for further reading. So thank you for kind listening, and see you in next lecture. Till then, happy learning.